Okay, before the break, we started looking at SQL, actually using a code. Whoops, wrong button. Started looking at SQL and the code that we use to control a database, which is a declarative interpreted language. So a bunch of keywords, and then we throw in a few others, as opposed to an imperative language where we actually have to tell the machine how to do that. Like store some value in a variable and then do the calculation and run through a loop. That's an imperative language, how to do it. Somebody already did the imperative part, and we just have those keywords to ask for things now. And we switch up the order that we ask for. We've actually, I'll do a little preview there right at the end before the break. We've seen almost all the words we're going to use today until we get to something that really doesn't apply, because our first example is not normalized. So started looking at this and we saw the first problem, something that flows naturally out of programmers. 5 out of 8 people in this course are software development majors. So you're going to be used to working with arrays, and you're going to make a database to go with your program that has all the data in arrays. But we can't even get to first normal form if it's in arrays. And if we don't get to third normal form, we can't guarantee all of our useful functionality from the relational database. You're going to see the second problem with it. Oh, and a better example of what compound data is, that JSON data type, which you will see in reference material called a data type, but it's not really a data type. The data type is text. And we just put a whole bunch of text there. Versus the standard example of a name where it's kind of debatable whether that's compound. First and last name go together. We don't separate them. So I'm going to throw that in and kind of show some of the problems we hit. So on the next one, and the speed will kind of pick up. For those that haven't had me in class before where we go through code, it starts slow and lots of details, but we've seen all our keywords now, so it'll go quicker now. So I'll just go across here and make the team table. Next. I'm going to add some white space here and do the inserts at the bottom, just to keep things somewhat organized. Organization goes a long way. Create table did not exist. Just because anytime we use create, that's a good idea to include that in your form, and we're going to make a team. And the SQL, the convention for SQL is to make your table name singular. A lot of people want to make it plural, but we're not storing data about employees. We don't have a data set about employees. We have lots of data sets about individual employee and individual employee. Hopefully that sentence came out right. Each record, each row is a single employee, or down here in the next table, each record is an individual team. So the standard convention is to leave that singular, not plural. Just like the convention is to write SQL in all uppercase letters, and our own stuff with a lot more lowercase letters. SQL is not case sensitive, but doing that makes it a lot easier to spot at a glance which ones are keywords and which ones are our references, right? And just glance and immediately tell where the all caps are versus the camel case or Pascal case in this situation. So what does our table have in it? Come over here, look at the picture. So we got an integer ID, a date time, right? We have different employees. They're going to mix together on different teams each day. Hopefully y'all kind of remember this situation. This is one of the first ones where we just made up a situation in class. So I have cleaned it up since then. What equipment is that team using? And who are the employees on there? And the equipment and employees are both plural again, so we store in arrays. So we need a team ID, nothing just flowed naturally out of there. So I'll say, make that an integer. I'll go ahead and put not null. I will probably stop typing not null before long. I think I've already started. I started at the very beginning, leaving off the word null. It's a good idea to be explicit. Okay? Everybody, I think most people have seen Python. You've all heard that statement, right? Explicit is better than implicit. One of the core concepts of Python, if you type imports into a Python terminal. So saying whether something is not null or whether it's null explicitly is a good idea. But for our example, seeing it over and over again, same thing with if not exist. We've already talked about that a couple times. And after a couple times, it starts to become clutter in the class example. We're trying to see we want to see the most important parts, so I'll probably start leaving off clutter for the rest. It's not really clutter. It makes a difference, but probably start leaving off that for some of the other ones you cut down to just the basics. Team ID, then we had the date, equipment, and employees. So date, but you'll notice pretty quick that the date, when I tried to give it that name, changed colors. It's a keyword in SQL, so the text editor recognized it. It's often a good idea to avoid those things. That happens a lot with words like name. Name is so generalized that it's known in a lot of places, so you want to be careful using that. Since date is a keyword, I'm going to change that to team date. Not much difference. And then it's going to be the type date time. So we have three different ones. There's date data types and time data types. They're all measured from the Unix epoch, milliseconds since January 1st, 1970. Midnight, January 1st, 1970, which is going to run out at some point in October 2038. So there's different epochs, and sometimes you'll have to encounter. So you might, whenever you're working in different languages, you want to make sure you know which epoch you're going off of. So there's different ones, that way we can realign everything runs out. Because time's inconsistent. Well, everybody around has probably used GPS at some point, right? Those GPS systems have to adjust for both relativities, for Earth being a large thing and for the satellites moving so quickly. So time is not as consistent as what people make it out to be, or what people think it is. So we can't even say exactly when we're going to run out of the milliseconds on the Unix epoch. We know it's October 2038, but like with leap seconds, all we can do is tell that one happened. We have to go back and add it in afterwards. It's like, oh, we missed a second. So there's different things, but make sure you know which epoch you're working off of. And date is the day, month, year. Time is the hours, minutes, seconds, milliseconds. Depending on the setting, milliseconds might or might not be on by default. Lots of formatting options, and the date time is the one that has both of them. We'll see when we insert that. Then we had some equipment here, which again is going to be passed in as an array because we're not in a normalized database. We're going to do that on Thursday. And 512 characters is hopefully enough to hold all that. So for an array, you just need enough text to hold the JSON array. To hold a JSON array, which means it has the keys and the values in it. Remember, it's not an indexed array, it's a key value there. Make sure you leave plenty of space. Oh, employees. And who is working on that team, and obviously the big one because we're not going to do much here. Then we need to set our primary key. Oh, I forgot a comma. Oh, I forgot that comma. I'm going to leave it off so we can see another error message. I like to throw error messages in the class examples because Usually if you're looking at tutorials and in textbooks and stuff, you see that finished, polished off version. And they just avoid all the error messages, but that doesn't really help you learn how to fix error messages, right? I have a big important one planned. I missed a comma, so I'm going to leave it off for now. And so we can see what happens with a typo sort of error. The primary key is going to be team ID. And might as well go ahead and insert some data into this one while we're at it. So I can come down to this insert section. Oh, did everybody follow along, get that? I'll pause there for a second. All right. And insert some data, which this time I'll do in one row just to change up a little. So insert into the team table. And I'm going to skip the fields and just insert into everything in the order they were created in. So we have the team ID, team number 1. Then we have the date. I will say now as a function. So we'll call the now function to just put in whatever the current one is so we can see the. So that for today, we can see what the default insert the current timestamp is before we do any formatting or anything. Then we need the equipment we're going to use. So maybe a JSON array and whatever this team was assigned to. Maybe they need a chainsaw. And a push bar. That sounds like lawn care stuff. And then another JSON array with, oh, we only have one team member so far, don't we? With Sally. We might need a second team member. Should we go ahead and insert a second team member? Oh, we have a plural thing. I see a head nod here in the classroom, so let's do that. If you haven't heard me say it before, copy and paste as much as possible. Typos are a human trait. Computers never make typos. So when you're writing your code, if you have a line of code that you know works, copy and edit instead of trying to type another one from scratch. And it's the same thing. So employee number 2, maybe it's somebody named Bob. Maybe Bobby this time, change it up. Or that was right. Bobby, and Bobby maybe makes a little bit more money. And he's good at grass and cleanup. It probably doesn't do the actual the chainsaw work. So that'll give us a couple employees in there, and then we can insert 2 in here. But as you can see, in one line, it's kind of a mess. So we haven't done the equipment yet, but does anybody see a problem with what I did here? It's in the picture. I was getting ready to go over to the picture. If you don't see it, let's look over at the ERD diagram. So here's the employees array, and notice that in the diagram, the planning this out, well, we need to connect our tables, and we connect our tables between the primary and foreign keys, right? So really, we don't need their names. We just need that ID. We don't need to store the data again. Let me write a line of something non-SQL on the board. I believe everybody's seen Python, or at least a little bit of logic somewhere. So if we had lines of code that look like this, x equals 3, y equals x, z equals y. Everybody's seen programming before. 3 is in all 3 variables, right? But how many times did we store the number 3? Just once, right? We stored it here, And then we just created another pointer to it. We stored it once, and then we point it. Then we point at the place where it's stored, and then we point at the place that points at the place where it's stored. So we have 3 ways to get to it, but we only stored it once. And that's what's happening in our database. So our ERDs, it looks like we have a lot of redundant data going on over and over again. Like all those things seem to be like they're showing up in all the tables, but really we stored that employee ID here, and ideally we want to point to it from here. So that was the thing I was hoping somebody would catch up on, that I was using names there instead of IDs. Should probably be using IDs. We haven't got to it yet. These are eventually going to be IDs as well. So maybe a 2 and a 7. But we'll make that table in a moment. And as far as this, we only have 2 IDs. Couple things there. One line is fine, but that's a mess to read, right? And in non-classroom examples, obviously those can get a lot longer than that too. So that's where the white space is for. That'll give us some data to tie it in. If I come over here and upload that again, I'll come over and delete the database because I might have already missed one of those, if not exist, lines. So drop the one that was there and go over to import and bring the file in. Oh yeah, I forgot about that comment. So that's what the comment error looks like. Left that in there on purpose because if you look at tutorials and textbooks, you always see that polished out finished version, and I think you all know that's not how it goes when we're working on it. We get the error messages. We need to fix those. This is another one of the nice ones. It tells us explicitly what went wrong. There's an error in the SQL syntax. I like this about MariaDB. They actually say check the MariaDB one. Other ones will just say there's an error in the syntax. It's one of our nice errors, and then you're supposed to find it afterwards. But with MariaDB, they remind you that you need to look for MariaDB and don't look for Oracle or SQL Server or Link or any of the other version SQL languages. And for the right syntax to use near these symbols, it looks like I have a team ID, closing parenthesis on line 7. So a nice error message there. That's why I decided to leave that comment out, because we actually don't have very many nice error messages in any of the SQL things. Our error messages are usually a mess, but we're going to look at that explicitly in a row. So on line 7, is that not a line? Use near team ID at line 7. But line 7 doesn't have anything about team ID. So you'll notice the line number kind of completely fell apart. So sometimes it loses track of what line's what. And the reason is that it does not count line breaks the same as we did. It's counting that end of instruction, or you can think of it that way, since that's what's going to show up in the error message. It's counting those semicolons. 1, 2, 3, 4. So 4 semicolons in, along with a couple extra lines. Somehow we tied that back and said this is line 7. So you notice the number, MySQL does not count lines the same way we do, or the same way your other programming languages would put that in. We're near team ID, so look at that. Look for the near part. sometimes they truncate it to not show very much. And it's hard to figure out which one it is, but it'll say what's something near there that you can identify. I assume that was there, unless I made another typo there along the way. We go erase that and bring that back in. Drop that database. There we go, all green this time, so it was just that comma, which was not on line 7 as far as the text editor, or we would count it. If we look at semicolons, it wasn't 7 of those either. It would be the 5th one, the 4th one. So it does not count things the same way we did. We get in here, we have our this is the employees. We go in the team, we see this data, and over on the ERD, I had that set up as a relationship. This is the problem with the compound data. This is why JSON shouldn't be used as a data type. We can shove it in, it's just text. JSON is just text, so we can show, as long as we have enough space to hold the text we have, it'll fit. And you'll notice that even some reference material said JSON is a type. Really, it's a type for when we select. When we get that and send it back to RAM, we can put it in JSON format. That's why we want to use JSON format, because now, if we look at the data set, how do we have it check one of those numbers? If we wanted to look for someplace where employee number 2 showed up, we had a problem, right? The only way we can do that is to bring all of that in to some other software that can analyze it and figure out what's inside of that array. We can't look for just the number 2. We have to have all of our text there. And that's where using JSON as a data type becomes. You'll see it in reference material because it doesn't throw an error, but that's what's really meant by compound data and all the reference material on normalization. For first normal form, arrays cause problems. We can no longer link. We have our employee IDs written or stored right here in the database, but we cannot connect them back to the other one because they're stored in the wrong way. They're not even stored as integers. We need something else. We need something that can read that text, convert it into an integer, right? ASCII code for 1 is 49. So right now that's stored as the integer 49, not as the integer 1. So it's in no way comparable to the actual ID that we want. That's the first thing that can go wrong if we don't go to first normal form. So that's why I keep saying normalization is one of the most important things in this course, up to third normal form. The rest of those are emergency situations, but yeah, up to third normal form, we have to get that far. Otherwise, we can't really rely on our database working the way it should. Like, I can't put a foreign key in here right now. That should be the next keyword we look at, right? Whoops, I spell it correctly. According to the diagram, planning this out, there should be a connection there, and then this should be a foreign key. But can't put that in there because it's we put the foreign key inside of an array, and we have no way to get to it in order to tie that back together. Whoops, wrong button. One line there. So I'll take that out of there. And we will see the normalized form on Thursday. I keep forgetting whether this is a Monday, Wednesday, or Tuesday, Thursday class, and I have to think it through every time. It's like, did I come to the office yesterday? Yes, so it must be Tuesday. Some more stuff. Moving across is the jobs table, and that's the one that really ties everything together. That's the one we really care about, right? That's the receipts for the customers. So we'll get that in a moment. We need our equipment table. So create table. If not exist. I just typed that out of habit. I'm so used to typing it. Did I do white space everywhere? Okay, let me do this one as a single line. Will that be okay? You know, follow it if it's a single line. You'll see this example a little later. Whoops. Just as a reminder that we can, it's personal preference. I almost always type SQL in a single line. But while I'm up here talking about good form and stuff, I should probably tell you not to do that because lines can get really, really long. And unless you're really used to doing that, it gets harder to parse, harder to find problems in, especially. So equipment, we have an equipment ID, just an integer, a serial number, which when I was getting ready, I thought, and I wasn't sure what to put in there. I'm going to go with 64. Some serial numbers get really, really long, right? I have no idea how much we need for a serial number, so I'm just going to leave a whole bunch of space. 64 seems like a lot, but I have seen serial numbers that require a line break on the label. Happens a lot on computers, right? You ever looked at the serial number of your computer, like the one actually printed on there, if it's on the case? A lot of times they'll be on the little plate, and that plate that's 4 inches long isn't enough to fit the serial number, so they have to include a line break because they need so many digits with so many numbers out there. What else did I put in the table? Equipment has type and the skill set needed to use that. So type is varchar and skill set for today. Oh, type varchar, 16 characters is probably enough. That's going to say things like mower, weed eater, lawnmower, weed eater, chainsaw, just one word things for what type it is. And the skill set will be similar for today. When we normalize it, probably it's not going to be characters anymore. Maybe 16 characters. What skill set is needed to use that particular piece of equipment? And then our primary key is going to be the equipment ID. End of instruction. So one really, really long line. I wanted to do at least one that way. Is everybody that was following along able to follow along there? Need me to scroll back, see different parts of it. Okay. Yeah. That's the way I prefer to do it, but hopefully you look at that line and like, okay, that's a mess compared to those with all the line breaks. And it's much, much easier to read that other way unless you're just used to doing this. I think the reason I do this is because I learned databases in the late 1980s and early 1990s. Like I told the story before, at that time, very few people knew computers, and the person that normally taught agriculture and headed the FFA club, he knew digital animation and databases. So every time there was a lecture, almost every time there was a lecture or class on computers on my way through elementary and middle school and high school, because he was still teaching it my senior year. That's what he had to show us. He knew a lot more by the time I got senior year. But unless they had a special teacher come in, like where I learned programming, we saw databases and digital animation over and over and over again. So I think that doing it in a single line comes from me learning it in the 1980s when the text editors weren't quite as nice as they are today. It was a single color back then too. So that gives us our table for that. And I'll go put some stuff in there. And as always, typos are a human trait. Let the machine do as much typing as possible. When we were talking about ChatGPT last week, I did show you how to get that, right? Get the results. Oh, we just did a quick example. We let ChatGPT use fields. If you want the SQL code, make sure you tell it what fields you want. So we did like equipment there. So you would ask for you'd ask the chatbot for an equipment table with a unique ID, a serial number, whoops, a type. Oh, and skill set still there at the end, and a skill set field. And you would just put that in the prompt for the chatbot and let the machine do the typing. Let the machine do the typing and the human do the thing. Because that whole I they put in the thing is not true at all. There's no intelligence there whatsoever. So double check anything it gives you. Human does the thinking. Okay, so what do we got? This is our first piece of equipment. It needs some sort of serial number. 1, 2, 3 sounds like a good serial number. What was this? Then type, lawnmower. And then the skill set this is what the employees that we labeled as grass people are going to have the skills to use a lawnmower. Oh wait, I put specific things up here, didn't I? 2 and 7. Okay, so this will be number 2. Oh. Okay, I'm going back to keyboard. Another thing from the 80s, a lot of people don't know this anymore. If you hold the shift key down, that's how we would highlight things before a mouse. Hold shift key and use your arrows, home and in. Home and in are on different spots on every keyboard. But if you're doing something where you're going to be writing code, you definitely want to know where your home and in keys are. So keep an eye on those. So paste that in the equipment. There was a number 7, maybe 3, 4, 5 for thing. It's a chainsaw. And we'll list that skill set as true. If one of the employees says they have tree skills, then we know they're able to use the chainsaw. Just to tie this in situational, right? Because the big thing from this class is, hopefully at this point, y'all are thinking SQL seems fairly easy. Maybe you're even jumping ahead of me, right? Since you have the picture there, you know where it's going to end up. You're thinking that's pretty easy. So once again, this job doesn't pay a lot for typing. Typing doesn't pay a lot. It's the thinking, the planning, the taking that situation that we made up I think it was week 2 of class. There's a lawn care company. We have this stuff going on in the lawn care company. Turning that situation into a database, into an efficient, usable database, which we don't have because today it's not normalized. We'll see the efficient, usable one on Thursday. That gets us that data. And also, for those who haven't had me in class before, you'll notice I'm jumping around a lot in this file. The SQL code needs to be in a specific order by the time it's ready to go into the computer. And quite often that order, the computer needs it is not the order we think of it in. It can be a lot more productive to jump around and put it together in the order you think of it in, as long as it's in the right order by the end. It takes some getting used to, because as humans, we're used to working top to bottom, left to right, which is another problem with tutorials and textbooks and things like that, where you see the finished product. You don't see how we got there. And jumping around can make a big difference. Put it together in the order you think about it. All right, so got some more tables to make. So create table. This time I'm going to do the line breaks customer. create a customer table. Oh yeah, like I know a semicolon's needed. I did that out of habit. I was just talking about that. It's at the end of the line, but I know it needs to be there, so I went ahead and typed that and then came back to put all the stuff before the semicolon. That way I don't forget it, because the stuff before the semicolon we have to think really, really hard about. That's why it's so easy to miss that semicolon at the end, because that's not something we think really, really hard about. And if we just focused our mind thinking really hard about a bunch of stuff, we're not in the right mindset to remember every little trivial thing, the things that shouldn't take a lot of thought to remember. So it's a good idea. So I like to type the semicolon first and then come back and do the stuff that goes before it. What do we have? So we have customer ID. Oh, well, customers are humans, so there's something that just jumps off the page as a unique identifier right off the bat. And then we don't need extra data in order to do that. So you might also remember that it was pretty far down that list of normalization forms before we add the native data explicitly. All the way down before everything has to come from the domain. And we don't have any more made up fields like integer IDs. But if we have one, it's good to use it. I don't know, 32. Does that seem like enough for an email address? Sometimes they get kind of long, the domains, maybe 64. Because yeah, if somebody uses a long username on a long domain, there could be a lot of characters there. But we have something. What else do we need from that? We need their name and address. And today I'm just putting that all in one. Name, varchar. I'll give about 64 characters for their name and their address. Varchar under 28. And again, it's debatable whether those are actually compound data fields or not, because the address is one thing. First name, middle name, last name, and suffix. I didn't look that up. It is just a suffix, the letters that go at the end, junior, third, fourth, fifth. All of that goes together. It's all part of the name. It's not separate names that we're putting together. So that's debatable on whether or not that's compound data. For a course example, seems like easiest just to do it all at once. Primary key will be the email. Oh, and I don't want to forget that comment. Is that all our tables except the last one? So we got employee, the team, the equipment. So we're ready to do stuff. Got a customer. So now we're ready to put all this together on the job to tie it back to our situation. And there's more than one way we can put this data together, right? So I said, I'm going to create this assignment after class asking you to list out the steps to normalize this. You're going to recreate it, do a diagram, and then we'll talk about it, look at different options. There's more than one way to do it. But the most common way is to tie it together to somehow represent the real situation. Like I just said, that is a sentence. We have our employee, our team, and our equipment, so we're ready to do stuff. Then we get a customer, and then we have all the parts that we need to tie together to make a job. So the tables represent the real situation as well. Makes it a lot easier to keep track of when we do things like that. And there's other stuff to put in here. And I have to make sure this is pulled up on my example, because I usually do this with the short form, not the long form. And I should definitely show you all the long proper form, because things can go wrong with the shortcuts. Shortcuts work, but they are shortcuts, not the proper way. The proper way is guaranteed to work, as long as we did our part. So we have a job table. Get that set up, come back and add some stuff for it. So there's a job ID in there, an integer, which probably not null. I'm just gonna skip that for now. Y'all have seen the word not null, and just think about what things have to be there. Primary key, guaranteed that you almost always want to put not null beside a primary key, unless at some point in the future you're teaching a database class and want to minimize the clutter on the screen during a SQL example, then you start leaving it off. That's about the only time you would ever leave off not null on the primary key. Because if a primary key is null, our database is broken. Since I said that, I should probably include it. I'll leave not null off the other ones, but just remember what explicit is better than implicit. So even if it's null, you usually want to type that, even though I'm leaving that off our example. What else do we have? So we had a job needs a customer, and a team, and the price of it, or cost of it. I'll go with price. Sorry, said that. So customer ID, and our customer was identified by their email, so that's a variable character with up to 64 bits in it. We need the team ID, who worked on the job, and that one was an integer. And we need the price for it. And it's money. The price is definitely going to be money, right? Sometimes lawn care stuff can be expensive. During that big windstorm a few weeks ago, a tree fell on my house. House gonna fall on a tree. I say it that way and it sounds wrong. A tree set down gently on my house. It didn't even knock shutters off. But it was a lawn care company that ended up coming and cutting that off. So those jobs can get expensive. So we want to be up in the thousands for the potential price. So maybe 7 digits, 2 of them after the decimal place. That would be a huge job. A lawn care company would come out, cut down a bunch of trees, pave a new driveway, and put in new cauldrons. Those jobs can get really, really large. So I'm thinking that would get up to $10,000. So it fits the example, but realistically, we could, a lawn care company at private estates in Miami or Beverly Hills, they could probably pass into that, into needing another digit for the work they do in some super high-end estate yard work with fancy statues and water features and all of that stuff everywhere. So always think about the situation and remember this needs to be the high end of what that's going to be if you do that for the money. Next up is primary key. We saw that. Primary key is going to be our job ID. And now we need to put some foreign keys in there because 3 of these things are stored on another table. I already erased the example from the board, but like in program, what we normally think of with a programming language, if we store the same, keep making new references, we don't store the value again. We just store a reference to the original one, and they show up repeatedly in the picture, but not in storage. So we need to tie those back as the foreign keys. So we want to explicitly state that we're putting a constraint in here and name our constraint. So a constraint of, let's do the foreign key team first. And I'm going to split this up. Notice I did not put a comma because all of this is things about that. So about this constraint. Then we need foreign key. E before I in that word. It's one of the words that shows up a lot and then just goes against what everybody's 3rd grade teacher told them. How everybody's 3rd grade teacher told them to spell stuff, even though when you get into like legal dictionaries and medical terms, these words by far outnumber the ones where I comes first, but that's a commonly misspelled word. So if you have typos, make sure you look at every place that you wrote the word foreign first, because everybody's third grade teacher told them to write the I's first. So it throws a lot of people off. And our foreign key is going to be the customer ID. And it refers to something. So that references the, oh wait, I'm on team, sorry. Team ID, to match this label, we'll do the customer in just a second. So that's going to reference the team table and the team ID field. Something else I'm going to add in there. Do I want to put it here or on customers? I'll put it on customers. So then we can make another constraint. I'll add some white space around here. So a constraint, it is this line right here is explicitly saying this line. So like the line from our ERD diagrams, it's like a chain. Constraint, tie it together, chain it together. Just like we have in our diagram, which happens implicitly if we don't put the word constraint, but explicit is better than implicit. So when you know that it's always going to be that, you might want to go ahead and give that line a name itself. Implicitly, there's no way we can access it. So as SQL gets more complicated, we might have times that we want to access that relationship, not any of the data that's being related. That's thanks for the DBMS 130 class, though, not for day one of intro to data analytics, or not for the intro to data analytics course. That's for the SQL course. So a foreign key, and I'm going to call that relationship FK customer. Again, it's a foreign key. Notice that it hasn't changed colors yet. The text editor didn't notice it was a keyword until both words were there. Here, it's customer ID. References customer ID. I want to add one other thing here, which is not going to work because we're not in third normal form. The two things that we need to change, if something happens, one of them, like on delete, when we delete stuff, make sure it cascades through. If we delete a customer over there, delete the records here too. We don't need to keep the jobs if we completely remove them. In this case, I don't think we would do that. But a customer might move, and then their address is going to change. And if we know their old address, we don't want to auto-populate today's work order with their address from 6 months ago, right? So on update, if we update things on either side of this relationship, we want to make sure that both tables know about that. This will not work today because we're not in third normal form. Customer would probably work, but those JSON data types we put in there, those arrays would prevent this from working. So these are the two important ones, and that kind of fits in situationally. Again, cascade, or actually update, we would want to restrict. So if we delete one, carry through and delete the records delete those customer records from both tables. But if we update the customer ID, we want the new address to show with a new work order when we bring it in, but we don't want it to come through and change all of their old work orders, right? If that work was done on Market Street and they moved to Main Street, those are good generic names, not the ones around here, but every town has a Market Street and a Main Street, at least every town in America, even though we don't have farmers markets in very many of them anymore. There used to be, that's what the town built up around, so every town has a Market Street. But if they move from Market Street to Main Street, we want our database to show that we worked on Market Street 6 months ago. But on the next job, we want it to show Main Street. So we don't want the updates to change the ones that are already here, just on the new ones. But if we delete something, we do want to delete it on both sides. So we need those to work. But if we're not in third normal form, those two things aren't guaranteed, which means you have to go through and check every record in your database to make sure the changes went through like they're supposed to be. This one would probably work. If it was on team, it would not, because team has that array. Team has the part that doesn't work. I want to make sure I include those in our example here. The extra white space. They're not really going to do much today, but that'll finish out the table and just some inserting some stuff in there so we can see it finish out. So customer, what do we just make? Customer and job. I think everything else was before the last round, wasn't it? Actually, I can look down here. So we insert into employee, insert into teams, equipment. So we need insert into, and I know that query works. I'm going to copy and paste that query. Insert into customer. We need at least one customer, and customers had an email, a name, an address. And we're going to do that one anyway. So email, maybe, I don't know, Susan@person.com. Just making that up. None of these names represent actual people. Name of Susan. Her address, 1234 Main Street. Pickville, Kansas. I don't think there's a town called Fakeville in Kansas. There could be. People have given towns funny names, but so made up out of there. And then a job where we tie this stuff together. So in our job table, we had a job ID and a customer ID, a team ID, and a price. And I actually left a big error in here. So if anybody's kind of drifted off, the last thing we're going to look at is a really big error and about searching. Because if you like had Python and gone over to Google to search for problems when you hit Python, it is a little bit different in SQL. So I want to cover those tips. That's the things that textbooks and tutorials always leave off. Because searching for a problem, Googling an error in SQL is not the same as Googling an error in Python. I put this one in here explicitly to cover that. What values am I putting in here? So job ID, this is job number 1. Customer ID, we only have the one. So Susan at, let's say person, yeah. Susan@person.com. And we have a team ID. We only have one team right now because it's all just test data, really. Oh, not price. And a price, maybe she had a $323 job. So there's all this stuff, and then the error that I put in, it's not in the insert query. If I come up here, does anybody see the error? We've been staring at code for a minute, right? So let's go run that, see what the SQL, a more typical SQL error is. You might have noticed that I was careful to explicitly state a little while ago that those errors that I threw earlier were nice errors in MySQL. Those aren't the typical errors we will see when SQL. Go to the old version, make sure I saved everything. Yep, it's saved. So import that. And we get a great big red box. Can't create table longcare.job. Notice, for those who have had a few software development classes, notice that wrote it out in object-oriented notation that we're used to. It doesn't say that lawn care database job table, lawn care.job. And if you want to take that further to tie into like other software, lawn care.job ID. So we have all that stuff. It is object-oriented things going on there. The problem is error number 150. Foreign key constraint is incorrectly formed. Let's go look for this. Copy. And this is what you would probably do, right? In like Python. Hopefully that's your first instinct in our modern world. Go do that. Okay, so it did do MySQL first. I think that's just Google because I've been doing lots of searches. I might recognize the MySQL, but remember there are multiple versions of MySQL. So I click on this, it's MySQL. I don't think anything would be different there. For those interested in the SQL class in the fall, notice that stuff at the end. We're definitely not getting to that here. But in those statements, we can say what engine to use. We don't have to use the same database engine for every table in the database. If we don't though, we better pay real close attention to which tables use which engine. Set up how much auto increment works by the encoding. So there's a lot more that we can do that we're not seeing here. Somebody asked this question on Stack Exchange this time, but they're all very similar. The 6 answers says they must be the same type. So here, varchar 64, up here, this one, varchar 64, so the same type, so that doesn't help us with our problem. Come back over here and we will see a lot of stuff. Yeah, then you start getting instructions like this. Like, go input these lines of SQL and see what it looks like in the background. See what SQL says and if they're different and all that. You'll see lots and lots of different things. Thing I wanted to make sure and mention, it pulled everything up. So what if I take out that error number 50? Error number 50 might have been more information. Usually we'll copy stuff like this. It's MySQL, MySQL, MySQL. SQL state, so that's actually going to a different one. Oh, there it is. SQL Server, it does. Google knows, the Google search bots know I've been looking at my SQL stuff lately. In particular, I think Google already knew I was looking at I was looking at MariaDB. The point I wanted to make is make sure you put in what database you're using. MySQL said that, or we saw in that earlier message, they remind you to check MariaDB. So make sure you check the right one. When he made MySQL, he made two of them, named after his daughters. There's Maya MySQL and MariaDB and MariaDB. MariaDB cost a bunch of money. MariaDB is free and has more features and is open sourced and more user friendly and all around just kind of nicer than the paid for version. I always thought that was an interesting thing, especially since they're named after his daughters, and it had to have been that way since the beginning. The friendlier, easier to work with one. Make sure whenever you're searching, make sure you get as explicit as you can. All my results were from MySQL because most of my searches lately would say MySQL. I always look for that explicitly. But be as explicit as you can and notice how the question was asked. He put his entire code in there. And then in responses, even the comments have code in them. Then the responses have the entire set of code. So unlike some of the other programming language, it is a lot more specific. You might be getting the same error messages, but not for the same reason. I checked through a bunch of these, and if we look through that list, but yeah, all the responses have code in it. That customization, we have these keywords. It's a declarative language. We use the same keywords over and over and over again, but there are infinite combinations of those before we even start making up our own words to mix in with it. So anytime you're searching for a problem, it doesn't in this case, but usually your search bar is going to start scrolling. You have to be very as explicit as possible when searching for stuff here. You won't find much on the general searches. And if we look at some other ones, key is incorrectly formed. The code looks very similar. Same one. I think that might be the same one actually. This is the top result. I'll go down a couple. Key is incorrectly formed. They put in their code, show where the problem's happening. Somebody threw out some code to refer to it, and same thing again. Pointed out that in your code, one of them is an unsigned integer, and the other one, or one of them is a signed float, and one of them is an unsigned float. So explicit things, and I already looked through a bunch of those. It's not going to tell us what the problem that I worked in here was. But I wanted to make that point be as explicit as possible. Most of your error messages are going to be vague and cryptic like this. It'll tell you what error number it is and a preset statement. But there are a lot of things that can give us that error, that preset statement, same preset statement. So let me drop that and fix the error because we're running low on time. Anybody that was following along figure out what the error was? So every place we looked, it said check the type. Varchar 64, Varchar 64. But that's not the only thing. Up here we call it email. Down here we call it customer ID, which is fine. But when we went to reference it, the current customer ID field references customer ID. But it's not called customer ID in that table. It's behind the pictures in the classroom. Let me move pictures. See that now, Joseph? So it's we gave it it has the wrong name here. And that if we would have followed by far the most common place to see that would be a type error, because there's so many different data types and subtle differences between the data types. Right? 6.2 is completely different than 7.2. Those are not compatible data types. So that's by far the most common one. So it's probably, yeah, I'll go ahead and say it, we never would have dug down, find somebody, a post on a forum that said, oh, the name got off. Which is also why I always like to keep the names the same. But that seems like a good place to work that into our example here. So things have to line up, be as specific as possible when you go to search for things. When you go search for errors, your scroll bar really should be, or your search bar should start scrolling. Should almost never have less than that to put in there if you hope to find good results. Upload that, import that. Got all green stuff, a bunch of zero returns. That's important for software developers, right? When we have our program doing this, we want to know what we get back. Since zero or positive integers, one row inserted, because I only did one test example. Zero or a positive number means it all worked, and a negative number means something went wrong. If we look at this, we see we have all our tables. Let's look at the picture. So designing it, everything looked up nicely, but we already saw there's problems, right? From that array, we can't really connect this integer ID to a whole bunch of integers over here. That's beyond the capabilities of the database. So we're not even in first normal form because of the compound data. If I come over here, I'm on the local machine. I noticed on my Mac it didn't have the design features either. When I put it on my Mac, it didn't have the design by default, but there's a list of plugins that can be turned on. So it is one of the plugins you just download, and it activates itself once it's downloaded. So the picture came up in not the best form, so let me move some stuff. That over there. The computer can draw the ERDs, it just can't organize them. I need to be able to see in order to organize this stuff. Oh. The move does not work the same in the Zoom call either. It works much, much smoother when not on the Zoom call, but I think Zoom keeps interrupting with it. So it doesn't quite match our picture though, right? All those compound data types in there, that JSON data type mess things up because we can't actually access that data. We can't do anything with it. So over here in the design, where some of those relationships depended on that, we couldn't actually do that in our actual database. That's where we need to normalize stuff. And up to the third normal form, we don't need to go further than that. And the sixth normal form is a theoretical thing. Nobody's ever going to take it up. That's like the theoretical top optimization that could never possibly be worth it for a human to put in that much effort. So, but domain key name form, if you have to do the full feasible normalization, we go that far. So we do need to normalize this so all our functions work. In particular, these two right here. That's kind of important, right? Hopefully you look at those words, think about what the words delete and update mean, and realize that those are very important lines that we want to work. We cannot guarantee those work unless we get in third normal form. So that's the importance of normalization. And then the problems with it happen afterwards. Does anybody have any questions about that stuff? Kind of a start. You have some pictures, right? I would recommend taking one of those ERDs you've done so far this semester and get some practice with that. I am making a new assignment though. So there's this database we just made. We're gonna do a normalized form on Thursday. So I'm gonna put an assignment out right after class that will be due Thursday at the beginning of class instead of the regular schedule. And it's not gonna be a huge number of points, but it'll be points, not extra credit. And at least list out the steps. I'm gonna say normalize this, but if you just want to throw some bulleted points in the document and write the steps, it doesn't have to be formal, neat, fancy, anything like that. Just write out the steps we need to get to third normal form. By Wednesday, I'll type that up. The instructions will be on iLearn in a few minutes. You can just write out the steps. If you want to just get this picture, everybody should have view access. So if you go over to file and make a copy, then you'll have a copy with edit access. And if you want to adjust it in the picture yourself, go ahead and do that. Any questions about SQL code before we wrap up though? See head shaking no here in the class. I'll give it a few seconds. Sometimes it takes a second to get to the mute button on the Zoom call. Okay, I assume 5 seconds of silence means there's no questions. If you have any, let me know. Otherwise, I will see you all on Thursday and we'll normalize that database and then adjust that code. We'll probably copy and paste from that and then edit it. I'll see you all Thursday. Have a good one.